Hi friends, my name is Bhumanand Barik and welcome to my YouTube channel. Today we will be discussing about a concept called bias and variance. Before proceeding ahead with a different algorithm, it is mandatory for us to understand the concept of bias and variance and respective concepts of overfitting and underfitting, so that it will be easier for us to understand further algorithms in data science. As you can see on the screen, bias and variance both are related with error. Error which normally appears during calculation of data science algorithm. As we have understood errors in linear regression. So the residuals, sum of residuals which we were calculating, during that we found error or the distance. So this error is also related with this bias and variance. If we take the example of linear regression, let's draw the graph here. In linear regression, we always wanted to find our best fit line. So this is independent axis, this is dependent axis, y-axis, and we always wanted to find this best fit line. To find this best fit line, what we did, we tried to create the parabola using a gradient descent or convergence theorem, and in that convergence theorem we tried to find out the m value, which was our global minima, like this. The global minima we tried to find, global minima we found, and based on the global minima we understood what would be our best fit line. Suppose our best fit line is best in our training set. Is there any guarantee that the best fit line will be best in test set? There is no guarantee, but we can assume that it will be fit properly on test set. So let's assume this line is best in training, while this line doesn't fit properly in test. That condition is known as overfitting condition. How that happens, I will explain you. Here, before proceeding ahead, I will be explaining one thing. This is called training. You can see on the screen, bias is related with training dataset and variance is related with test dataset. You can see bias is related with training dataset and variance is related with test dataset. So I'll be create the diagram over here. As you can see on the screen, if we consider this is best fit line, so there are different data points also present in the graph, different data points over this best fit line and under this best fit line, and this red lines are known as the distance or the error or the residuals. So all the points doesn't fit the line, or the line doesn't fit all the points. So it is calculated, the minimum distance is calculated here. So here there are various data points present which doesn't satisfy the condition. So this condition, if there are so many data points are present in the data for which our line doesn't fit, in that condition, as we can say, this is known as high bias. High bias condition. While in the same condition, if we draw another graph, so there are various data points here, and for these data points, if we say there is a line which covers all the data points, it means when we are calculating, all the data points are falling on the line. It means this is called low bias. And both this bias condition, both these bias graphs considered for training. When we are training our model, that time if it is fitting properly, then it is low bias. If it is not fitting properly, then it is high bias. Let's come to variance. What is variance? Now suppose the model is trained. So once the model is trained, the model will be applied on test dataset. So here this model is trained on trained dataset. This is trained dataset, and it has to be applied on test dataset. When it is applied on test dataset, we found something happens. It was fitting properly while training, but in testing it doesn't fit properly. Doesn't fit properly means in training the line was something like this. It was fitting properly. But while testing, there are various points in which distance is higher. We can say here the distance is higher. So various like distance or residual or error is quite high while fitting the model. This condition is known as high variance. This is known as high variance. Ensure a variance word comes with testing and bias word comes with training. As we have seen, so this kind of still data points are here. It is not fitting properly. So this is called as high variance. What is low variance? Low variance means whatever the line is there, it is having minimum data points, minimum distance is there. Or if we draw the graph in different way, if it is like this, there is no much error. Error is very less here. So this is known as low variance. So while building a model, what is our goal? Our goal is to make low bias and low variance. So this should be our goal, to make a generalized model. So we can say to make a generalized model, our goal is to make low bias and low variance. So when do we get high bias and high variance? When the data set doesn't fit properly while training. While training, it doesn't show like good result, bad result, we can say like. At the same time, if it is not fitting properly in training, we cannot even estimate like it will fit good in testing. So training itself is like unsuccessful, so it doesn't fit well in testing also. While testing also, this doesn't fit. So here also we are getting high variance. So high bias, high variance can lead to underfitting. This term is known as underfitting. It means neither it fit in training set nor it fit in testing set. Now the question is, when do we get low bias and high variance? Low bias means when in training it fits well, and in testing it doesn't fit well. So in this condition, this term becomes like overfitting. Overfitting means we are getting 100% accuracy in training, and it is giving us less than like 50% accuracy in testing set, or less than 60% accuracy in testing set. So it seems like if it is 100% accuracy, someone can blindly understand something is fault there, some problem is there in the training set. If everything is fine, then 100% fitting means it can lead us to overfitting issue. I can tell you the name of some of the algorithms. If those algorithms are expanded extremely, it can lead us for overfitting issue. So as we have understood, a generalized model must have low bias and low variance. It means while training, it must fit well. If any error is there, then there must be very minimal error. The error must not be very high. While fitting also, it must fit well. There should not be any high variance kind of issue. So it has to be low bias, low variance. So as I have let's understand about a different algorithm. The algorithm is like a decision tree algorithm. Decision tree algorithm means it is a kind of binary algorithm like this. It has to expand. I'll draw the diagram. In decision tree, a tree will be splitted into its like branch, and further it has to be splitted to leaf like this. I'll be making a separate video on decision tree algorithm. Suppose this decision tree is expanded extremely, like if it is expanded extremely, it will fit properly. Sometimes it leads to it fits exactly, and this extreme fitting is known as here overfitting. When it is like expanded extremely, it is known as overfitting. So a decision tree model which is expanded extremely turns into high low bias and high variance, as I have told earlier. At the same time, there is one more algorithm which is known as EXA Boost algorithm. This is also one of the algorithm from ensemble method. EXA Boost algorithm, it consists of multiple decision trees. So there are various decision trees are also kept in EXA Boost algorithm. So in this EXA Boost algorithm, various decision tree methods are used. Various decision tree methods, more than one decision tree methods are used. That's why when we find the output in training, it doesn't seem good. It gives us high bias situation. While in testing, we get low variance. Low variance means it fits well. So while working on EXA Boost, we have to gather most of the weak learners, and all these weak learners are combined together to form like low bias and high variance, like low bias and low variance kind of output. So as the various weak learners are combined, so this high bias doesn't come into picture and high bias turns into low bias. So once we get low bias in training, ultimately we are getting here low variance. So it fits well. In linear regression, while we are working on linear regression, there is a condition overfitting can appear. Suppose the question is, if overfitting is appearing, what to do? Should we proceed with linear regression, or is there any other algorithm which we can implement? Yes. During that time, there are two different algorithms. One is known as ridge and lasso regression. Ridge regression and lasso regression. There are two different algorithms which we can implement to overcome this overfitting issue. As well as we are overcoming this overfitting issue. At the same time, here this lasso regression also helps us in feature selection. So suppose there are some 100 features are there, and out of those 100 features we need only very few features. So this algorithm itself can decide how many features has to be present for model calculation or training. So if you like this video, please share and subscribe. Thanks a lot. We will be explaining these two algorithms in my next video. Thank you so much.